Hi there, my name is Miss Harlabidis, and in this video, which is just another video from my own series of videos on the AP Pre-Calculus content, we will see how, through a method which is called method of successive differences, we can actually determine the degree of a polynomial function. So let's see how it works, and then we will go directly to example 112. The degree of a polynomial function can be found by examining the successive differences of the output values over equal interval input values. This is too important. The interval input values should be of the same length. That means that it should have been, like in my own example, from -1 to 0, that's a difference of 1. From 0 to 1, then again, another difference of 1. From 1 to 2, another difference of 1. And from 2 to 3, another difference of 1. If instead of 3, we had 7, or if instead of -1, we had -4, this method would not be applicable. So, now that we have seen that we have equal interval input values, let's see how this works. We need to consider the differences. I know that when x is -1, y is 5. When x is 0, y is 2. The difference between 5 and 2, 5 minus 2, it's 3. Then the difference between 2 and 1, so let me do them in a more clear way. 5 minus 2 is 3. Then 2 minus 1 is 1. Then 1 minus 2 is -1. And then 2 minus 5 is -3. These numbers, are they the same? No, they are not. In case they were, we would have said that, okay, this is a polynomial of first degree. Since they are not, I will keep up with the next differences. Let me change a color. These two, 3 minus 1 is 2. 1 minus -1 is 1 plus 1, it's 2 again. -1 minus -3, it's the same as -1 plus 3, which is 2. Are these differences the same? Yes, they are. So that would have been the second degree, because I got the second differences. So the polynomial, in this case, it would have been a second degree polynomial, which makes it a quadratic. Let's work on the next exercise as well to understand it even better. The table gives values for a function f at selected values of x. It is, which of the following statements is true? F is best modeled by a linear function, so this makes it the first degree, by a quadratic function, by linear, by quadratic, and we will see. The only difference here is that the values themselves were given horizontally. Let me do them vertically in case this helps some of you. -2, -1, 0, 1, 2. It's always important to double check whether the x input intervals are of the same length. They are. From -2, in order to go to 1, it's a space of 1 unit, then another unit, another, and another. And the y values are 6, 3, 2, 3, and 6. Let me take the first differences. 6 minus 3 is 3. 3 minus 2 is 1. 2 minus 3 is -1. And 3 minus 6 is -3. So we are certain that since these numbers did not end up to be the same, then my polynomial is certainly not a first degree one. So it's not a linear function, which means that A and C should be rejected. Let's move on. 3 minus 1, it's 2. 1 minus minus 1, it's 1 plus 1, it's 2 again. Minus 1 minus minus 3, it's minus 1 plus 3, it's 2 again. Here, I ended at the same number. So this was the second time I was calculating these differences. This means that it's a second degree polynomial. So both B and D are correct. It's modeled by quadratic function. The reasoning of B is a wrong one. It states that that happens because the average rates of change over equal length intervals are constant. No, that's not it. It's because the successive second differences are constant. That would have been D. And that was all. Remember, always check whether the X inputs are of the same distances. If they are, start taking step by step the differences between the Y values, and that would be all. Once again, as always, thank you for watching.